Why does bee health matter? I'm Marla Spivak from the University of Minnesota, and I'm going to discuss the science surrounding honeybee health and what we can do about it. I'd like to thank our task force members, the co-authors of our paper, our reviewers, and our liaison to CAST. So why does bee health matter? The short story is this. This is our life with bees, and this is our life without bees. Bees depend entirely on flowering plants for their nutrition, and while they gather nectar and pollen from flowers, they move pollen from flower to flower, which is vital for seed, fruit, and nut production. In this way, bees are the most important pollinators of fruits, vegetables, flowers, and crops like alfalfa hay that feed our farm animals. More than 1/3 of the world's crop production depends on bee pollination. An example of the importance of bees to agriculture and human nutrition is the almond crop grown in California. 1 million acres of almonds are grown in the Central Valley of California. We are the major exporters of almonds to the world. Almonds are completely dependent on bees moving their pollen from tree to set nuts, to set the almond. The scale of almond production requires that the vast majority of colonies in the United States, around 2 million hives of bees, be trucked to California to pollinate this one crop that blooms in late February. And after pollination, the bees must be trucked out because there are not enough flowers in Central California to support the nutritional needs of 2 million colonies year-round. Many commercial beekeepers, those that earn their livelihood from beekeeping, derive the majority of their income from renting their colonies for pollination services of almonds, blueberries, cranberries, apples, and other crops. Although honeybee colonies are distributed among all the states, and honey is produced by these colonies across all the United States, the greatest amount of honey production and highest colony numbers are concentrated in a relatively few number of states, such as the upper Midwest, California, and Florida. So the states in yellow are the highest honey-producing states in the nation, and the arrows signify the pollination routes of migratory beekeepers that move their bees to different locations to pollinate crops like almonds in California or along the eastern seaboard with blueberries and cranberries and vine crops, and up to the summer months to produce honey, or down to Texas for the winter to produce more queen bees and colonies for other beekeepers. In the last 10 years, the public has taken a keen interest in the plight of honeybees. Backyard beekeeping has become increasingly popular. But despite that, both backyard beekeepers, sideline beekeepers, and the commercial beekeepers, all of them are losing a substantial number of colonies every year. The national survey data, here collected by the Bee Informed Partnership, reveal that annual colony losses hover between 30 and 40%, which exceeds the 15-20% that beekeepers deem acceptable. This means that beekeepers have to make up their losses by dividing the surviving colonies into two. And they have to make up their losses so that we have sufficient numbers of colonies to pollinate all the crops throughout the United States. There are about 20,000 species of bees in the world, and all are just as important for pollination as our managed honeybees. We know that both of our honeybees and our native wild bee species are at risk. This year, the rusty patch bumblebee, Bombus affinis, was put on the endangered species list. This is the first bee ever to be listed. So why are all these bees dying? Research is documenting the many stresses honeybees are facing, and these stressors are very similar to those that wild bees face. Most scientists agree that there are 4 main stressors: parasites, pathogens, pesticides, and poor nutrition. My conceptual diagram here shows this in a different way. On the left in blue are the honeybee problems, which show the parasites and pathogens, and they're tied to the environmental problems on the right, shown in green, which include all the pesticides, insecticides, fungicides, and herbicides, and the poor nutrition that bees are confronted with due to a lack of flowers. And I hope to show in this talk the importance of nutrition as a key way that we can help bees get back on their feet. To begin, I'll talk about honeybees, parasites, and viruses. The Varroa parasitic mite is specific to honeybees. And this horrible pest originated in Asia and was inadvertently introduced into the United States in 1987 via global movement and transportation of bee colonies. The effects of Varroa on bees, when Varroa feeds on the bees, they reduce the bees' lifespan, they compromise the bees' immune systems, and high infestations of these mites in a colony can lead to colony death, especially in early winter. But the worst problem with these mites is that as they feed on bees, they pick up bee viruses that are otherwise not a problem for the bee, and they transfer these bee viruses from bee to bee with their mouth parts like a dirty syringe. And unlike human and mammalian immune systems, the honeybee immune system has no antibodies, so there is no effective way to vaccinate bees against these viruses. When bees are infested with Varroa mites and they have these viruses, they are more susceptible to other diseases and the effects of pesticides. So to control the mites and hopefully to also reduce the viral levels, beekeepers reluctantly have had to resort to applying treatments or miticides within their bee colonies. But the continued use of these miticides leads to other problems. The mites develop resistance to the treatments, and the treatments leave residue in the comb that can harm the bees. Beekeepers really need new and novel approaches to reduce reliance on miticides and to improve bee health. One solution that was originally funded through the USDA National Institute of Food and Agriculture program to Dr. Dennis Van Engelsdorp, myself and others across the United States, was to establish the Bee-Informed Partnership, which created all the survey data, generated all the survey data, and created the first national database on bee health. Through the Bee-Informed Partnership, we formed tech transfer teams, or groups of professional beekeepers that help commercial beekeepers monitor the disease and mite loads in their colonies. Now the Bee-Informed Partnership is extremely successful. It is a nonprofit, and we're seeking permanent funding so that we can extend the reach, extend the number of tech transfer teams, and extend their reach to many more beekeepers across the United States. Another solution is that we're starting a mite check program focused primarily for backyard beekeepers, but for all beekeepers. And this new program could help beekeepers become more informed about the levels of mites and diseases that cause damage to their colonies. So it's simply a method of sampling colonies to determine how many mites are in there, and so that beekeepers can make effective management decisions and treat their colonies only when needed. Additionally, finally, another solution to the mite problem is that honeybees can be bred for behaviors that decrease disease and mite levels. This has been the topic of my research at the University of Minnesota for many years and of others across the U.S. But again, many more concentrated efforts are needed to really develop a bee that's able to withstand the mites and the disease pressures. So that briefly discusses the honeybee problems on the left. What about the environmental problems? What about pesticides? Researchers have been looking at the pesticide residue in bees' pollen that they carry home as food. So the orange blobs on the hind legs of the bees are pollen loads. And we've learned that every batch of pollen collected by a bee contains 5 to 6 detectable pesticides. And that includes every class of insecticides, herbicides, fungicides, and even unlabeled and potentially toxic adjuvants. One class of insecticides, the neonicotinoids, has made the headlines across the world. Neonicotinoids are systemic, meaning they move throughout the plant, and so they can go into the leaves where they kill leaf-munching insect pests. When they're applied in high concentration, such as in this ground application, They move through the plant and into nectar and pollen, where bees might feed on a lethal dose and die of acute toxicity. It's important to understand that other classes of insecticides, in addition to the neonicotinoids, also are sprayed or drift onto flowering plants in high concentrations and also can result in acute toxicity to bees and other pollinators. In some crops, only the seed is coated with a neonicotinoid insecticide, like this sunflower seed in pink. If this was a treated corn seed, at the time of planting, the treatment can blow off as dust and drift onto nearby flowers, causing acute toxicity to bees that are foraging on those flowers. Chemical companies are currently devising ways to eliminate this dust off, but for most seed treatments, only very low concentrations of systemics move through the seed and into the pollen and nectar, and these sublethal concentrations cause effects like the bees are disoriented, intoxicated, and possibly unable to find their way home. The sublethal effects of all pesticides on bees and butterflies is a new area of study and requires much more attention. Do herbicides affect bees? As far as we know, it's only indirectly. Herbicides are designed to kill weeds, but many of these weeds, are flowering plants that provide important sources of pollen and nectar, nutrition for bees and butterflies and other pollinators. As Zach Browning, a commercial beekeeper, one of our co-authors from North Dakota, states, in some parts of the United States, honeybees, wild bees, and other pollinators are reduced to feeding on scraps. And we know that these flowers provide such good nutrition and health benefits for bees. There are compounds, phytochemicals, in floral nectar and pollen that bolster bees' immune systems to help them fight off diseases. And these compounds also turn on genes to produce enzymes that can detoxify some of the pesticides. So having good, clean food and the compounds in good floral nectar and pollen really help bees fight off diseases and pesticides. So our greatest challenge going forward is to figure out how to protect our pollinators while we use pesticide on our crops. And it doesn't have to be just corn and soybean crops. All the other crops, flowering crops, such as apples and almonds and blueberries. It could be our front lawns. How do we have a front lawn and protect our pollinators? How do we have a golf course and use pesticides on roadsides and protect our pollinators? How do we protect our waterways? Good communication among beekeepers, growers, and pesticide applicators is of course key, but we need more things. For example, toxicity testing and risk assessments should be performed on all new pesticides, including fungicides for honeybees, native bees, and their larvae, before they're approved for widespread use. Another best management practice is to curtail the off-target drift of all pesticides. Drift from a crop or the spraying on a lawn is the main source of bee kills. Dust off from corn seed, spray applications of insecticides, fungicides, and herbicides on crops and in urban settings are the major source of bee kills. Despite all this, we are experiencing what I call a glorious pollinator landscape revival. The increased awareness about the plight of bees and monarch butterflies has motivated people across the United States to plant flowers for them in cities like this and in agricultural settings. But we need to target our efforts in locations likely to most benefit from the presence of new pollinator forage. This map shows the reduction of conservation reserve program in the upper Midwest, shown in red. The reduction in CRP is happening exactly in the states where the greatest amount of honey production and highest colony numbers are concentrated. This conversion of grassland to cropland eliminates flowering plants that honeybees, native bees, and monarchs depend on for forage. The National Pollinator Health Task Force of 2015 called for coordinated efforts across government agencies to address these issues surrounding pollinator decline and how we could increase forage for bee nutrition. The USDA NRCS has multiple conservation efforts, including CRP and the EQUIP programs, environmental quality incentive programs, but we really need more financial incentives for planting pollinator habitat in more locations, for example, on marginal farmland. And these incentives could be and should be negotiated through the U.S. Farm Bill. In addition to marginal farmland, pollinator plantings could be established along roadside ditches, utility corridors, solar arrays under solar arrays, and as cover crops to remediate soil, and also there are new cover crops that produce oilseed, which are very lucrative crops that flower and provide nutrition for bees. We could even have flowering lawns in our city by planting low-growing flowers that you could continue to mow to provide food for bees. We can untie this messy knot. Just my presence today and your attention is a huge step forward toward protecting our valuable bees and pollinators. Thank you for this opportunity.